Hello everyone, welcome back to alkaline hydroxide 784, and today is possibly the last episode of the physics series, which is episode 22. And let me just clear my voice a bit. So this episode will be covering the final paper, which is the practical. Oh wait, I didn't take out the syllabus yet. Let me just do that. Oh my. Okay, so basically we will start with looking at the description in the syllabus, and yeah, then we will move on to the process itself, and then the different things you need to take note of for paper 4. Okay, so practical is paper 4 in the syllabus, but it happens before all of the other papers, so I mean, well, nothing really much to say about that. Definitely, it's kind of clear that the numbers don't reflect the actual order of the paper. So, yeah. Anyway, so paper 4 is according to the syllabus to assess appropriate aspects of some objectives in planning, manipulation, measurement, and observation, presentation of data and observations, analysis, conclusions, and evaluation. And yeah, so the planning is referring to that question at the back where you have to write a plan and also draw some stuff. And the other stuff is what you do during your experiments. So we'll be going through these in more detail later on when I mention what you need to take note of. It kind of actually helped me remember what happened in practical. Oh my. Anyways, so overall the entire 2 hours 30 minutes will be accounting for 20% of your grade. So it is actually quite important to do well in practical. It may mean the difference between an A and a B. Who knows? Okay. And yeah, the assessment of the presentation of data and analysis thingy may also include questions on data analysis which do not require practical equipment. And yeah, I'll just go through that in more detail later. Okay. Right, so now let me go to my actual document, which will talk about the whole process in general. I didn't actually write it in the document, I have to tell it. Okay, so the whole process, of course, if you actually have any other like practical assessment, it usually would just be part of your lessons. So you just get like one short quiz or something, and then like not like a shortened version of the practical, like 1 hour long or something, and then you have to practice that, or you'll get planning questions in your tutorial sessions or something like that. So that is apart from your prelims and A levels time. That's how you'll be doing the practical for the most part. But once you get to the prelims, they will follow the A level format because you need to know how it works, right? Like how the whole thing goes. So for prelims as well as for A levels, how this will work is that they allocate everyone to 3 groups: the morning, afternoon, and later afternoon, I guess. And they'll ask you to come at the specific timing for your practical. So the idea is because usually you don't have enough space for everyone to do the practical, but if you actually do have enough space for everyone to do it in one or two sittings, then maybe that's how the scheduling will go. So I don't know, it depends on the JC. But yeah, that's the main thing. Then what happens is that the labs will all be used, and they will be separated in such a way that you cannot really cheat. Like there's like partitions and everything. Should actually be quite suitable for this situation. Very good for that kind of thing. But the real purpose is for academic integrity. Yeah. Okay, cool. uh yeah, so let's say if you're the first group, you come in the morning, and the first thing you do before you enter the quarantine area, so not really quarantine, it's the waiting area, right? Waiting area is they'll check your IC, And of course you can bring your notes and stuff like that, because before your test you can go ahead and read whatever you need to read, because they'll be taking some time in order to before they actually send you off to the lab. So of course beforehand make sure to know which lab you're going to, what group you're in, and what seat you're at, because that helps a lot with the whole process. So when you enter, they'll be checking your IC and making sure that you're there, like your attendance, I guess. Then you go in with your notes, your stuff, everything. Try not to bring a bag, because like don't bring a bag, but bring the stuff instead. Yeah. If you have a lot of notes and stuff, I recommend bringing like the box file, the stuff that JC students always have, like that kind of file that they always use, the one that looks like a box and then there's like two clips on it. Yeah, that one. You can keep your notes and some of your stationery in there, and to make your life a lot easier. Kind of, but try not to bring a bag. Keep your bags and your phone and wallet and stuff like that in your locker before you come. Just bring your IC. Yeah. So inside the waiting area, you'll just be sitting there and studying your notes, and then at some point of time the teacher will come and, like, the teacher aka invigilator will be telling you what to do, I guess. Like, they will be telling you, okay, this you in 5 minutes time you'll be going to the lab or something. Then they'll tell you when you can until when you can go toilet and stuff like that. And yeah, when it's time to go to the lab, you'll go there, and then outside the lab you have to leave all your notes and stuff. If your JC is nice, they'll give you a nice waterproof box to put everything inside. Put your notes, put your water bottle. Yeah, so drink water before you enter. Put your water bottle inside, and then put whatever is not essential and not allowed inside. So yeah. What you can bring inside the lab is your stationery, of course, so please do bring your stationery. You can bring your calculator and stuff like that. So if you have a GC, make sure to clear the data beforehand and show it to the invigilators inside. And then you definitely must bring a long ruler, and if you want your French curve or the bendy ruler that people like to use, that one, to draw curves. And yeah, but yeah, just make sure you have all your stationery and stuff. And you do not need to bring a jacket inside the lab, because the lab is not going to be cold. It's going to be pretty warm after a while. They don't really use AC. They'll just, yeah, there's no AC in the lab. The windows will all be closed, so there's no ventilation whatsoever. It's completely warm, super warm there. So yeah, that's how it's gonna be in the lab. You don't need a jacket for the lab, but maybe you can bring it for your waiting or your quarantine area later on, because it's AC there. But in the lab, no. Okay, and then your water bottle must leave outside, so just drink enough water before you go in. And yeah, just about as much as you need. Just bring your IC, and if you have like tissue or something, you can bring it in, but why? Okay. Yeah, so just make sure that you don't have any illegal stuff when it comes to exams. I mean, yeah, don't bring any notes and stuff inside the lab. So once you're inside the lab, you can keep all your stuff. Like, please keep it neatly in one corner, so that it'll be easier for you later on when you're doing experiments. You don't have your things all over the place. You can keep your stationery ready and stuff like that. Keep the IC at the corner that they tell you to keep it at. I think it's like the rightmost corner or something. And oh yeah, make sure you have your exam exam proof. What's that thing called? That piece of paper you bring for all of your exams. Yeah, you need that as well. Bring that in as well. Yeah, that's about it. And if you have any excess, what's that thing? Assistive. No, that's the wrong word. Okay, but if you have any special assistant that you need or something, and you have a piece of paper for that, you can bring that as well. I don't think it's really there for practical. I'm not sure. Maybe if you're colorblind or something, you might have it. I don't know. Yeah, so just bring that if you need to bring it. Yeah, so once you're in and you put all your stuff, the invigilators will tell you when to begin. And they'll first of all give the paper, and then they'll tell you, okay, this is gonna happen at this point of time, this will happen at that point of time. So the idea is that for physics, usually the two different experiments, or like not two different experiments, but two different sets of experiments will be placed on the table. And the way it works is that they kind of pair you up in, I don't know, like you're not doing pair work, but you're supposed to switch with another person. So first, if let's say there's two people, A and B, so A is gonna be doing one set of, like, set A of the experiment first, then B is doing set B of the experiment. Sorry, maybe that's not the right way to put it. Okay, A is doing set 1 of the experiments and B is doing set 2 of the experiments. And then after like 1 hour, A and B will switch, and B will do set 1, A will do set 2, and after another 1 hour, you stop touching all the experiment method, that is stuff that's there for the experiment, and then you start doing planning for the last half an hour. So that's how it works actually. So you will not have access to the materials after that 1 hour that you're given to work with them. So for the set A, you can only work with them in that 1 hour, and then set 1, you only work with it in the 1 hour, and then the other set you have to work in it in that other 1 hour that you have. So according to what experiment you have, you do that one first before you do the other one. And it may be more than one experiment in that set, so that's why I said a set rather than the experiment itself. So your paper will have like the demarcations of all the experiments that you had to do. And I do suggest that you follow that, like follow what order you're doing the experiments in, and make sure to finish the stuff for that one experiment first. At least collect the data and finish all of that the main data collection part. So if you're the kind who has a certain strategy that, oh okay, I want to draw the table for everything, then you can do that, but first finish collecting the data for your set 1 experiment before you go to draw the table for the next one. If you are scared about not having time to collect data or something, you can do that. But if you're the kind who want to really go through that, finish that one experiment first before you do the next one, as in including the graph, all the calculations, everything, then you can do that. That's up to you. So just take note of this when you strategize. Yeah. As for the planning, if you are done with your second set of experiments, or even with your first set, and you are kind of free and you don't know what to do with you can't really do anything for the second set of experiments yet, then you can start doing your planning as well. It's perfectly fine. But in the last 30 minutes, you'll not be allowed to touch any of the experimental materials, and you can only do planning or the calculation questions in any part of your paper. So your paper is completely accessible to you throughout the entire 2.5 hours. It's just that experiment materials itself will not be available at a certain timing. So just take note of that. Yeah. Okay. Great. So yeah, that's the main idea of what happens in the lab. And after the 2.5 hours, everything is done, and then you will be going out. If you have any feelings about the entire thing, I don't know, you can think about it in the quarantine room. So they'll bring everyone to the quarantine room. Of course, take your stuff first, like the stuff that you kept in the box. Then you go to the quarantine room, which is usually like a hall or something, and it's usually AC, so you can just do your homework there. And if the teachers are not too, a bit chill, you can just talk to your friends as well. Like, don't talk too loudly, but you can talk to them there. The reason why there's a quarantine room is because they don't want people sharing the answers with the next bunch of people coming in. But if you're the last group, you probably don't really need to be in the quarantine room. So I don't know, it kind of depends on your group and what time and it starts and ends. So yeah, that's the whole process. Like after the quarantine part, like once they think that everyone from the next batch has come in, you can leave and you can go home and rest. I don't know. Yeah. So that's the whole process. And now I'll be talking about the different things within the practical that you might need to think of, in a sense. I think one thing that I mentioned just now is the fact that you can only access the experiments for one set for 1 hour, right? So if you're the kind who is worried about your data suddenly not being very linear or not being very trend, like it doesn't follow any trend whatsoever, and then you want to redo the measurements, you should probably do it as soon as you actually collect all of the data. You should make sure to know that, okay, the data I collected, you can look at it and then you can tell whether it is actually following a trend or not. Like, just you should have some kind of intuition in a sense. Or if you really don't have any intuition about it, then you should probably draw the graph and see whether there's a trend. If there isn't any trend, you might want to do the data recording before the 1 hour is over. Yeah. But generally, if you follow all of the instructions and you make sure that all the materials are there and you use all of the materials that are there, you should be fine. But even if you do mess up something, usually you will get somewhat, like, you get data that follows a certain trend, either a linear trend or I don't know, a curve or something like that. So don't worry too much about it. But if it really does not follow anything, then I don't know what to say. You can probably try to bluff it, but that means you require a certain amount of knowledge about the way the experiment works, as well as the actual topic. So unlike chemistry, physics, experiments can be from literally anywhere and anything. So it's a bit hard for me to, to categorize them based on the topic or something. But yeah, of course it's gonna be within your syllabus. You're not gonna test you with some trying to analyze some, I don't know, space rock or something. They'll be asking you to do something that's very somewhat familiar to you, either theoretically or practically. And that's why it's very important to remember your theory, even though this is practical, because if you know your theory well, and if you know the equations that come from the theory, once you see the practical and the equations inside the practical, you should know pretty well what to do, or at least know, you understand the instructions better lah, in a sense. Yeah, so that's for data collection. So when you're collecting your data in your table, make sure you draw your table first lah, because I think drawing the table first is quite helpful when you want to write down your data. And of course, even if I draw a table, I'll be writing stuff in the pencil first before I actually transfer it to table. But oh, my grammar is GG right now. Okay, the thing is, even though I draw like it is important to draw a table, even if you're the kind who tends to write their stuff in pencil and then transfer it in pen to a table, because the table will help you remember what you're supposed to be measuring. Yeah, that's the point. That's all I wanted to say. Yes. So after you finish the table, of course, please remember the rules of the table lah, like independent variable on the leftmost column, and then the dependent variable next to that on the right, and then all the calculated variables, which is based on what you read in the instructions. Yeah, that's about it. Follow your DPSF rules, and make sure to write the units correctly on the table. So for that you need to know what you're measuring and with what instrument you're measuring with. If you're using a ruler, vernier calipers, even micrometer gauge, yes, it's possible for you to be using that. So please know how to use those things and worry about zero error and stuff like that. So do remember that. And or if you're using a mass balance or something of that sort, you need to know what the accuracy of that mass balance is, or whatever instrument that you're using, you need to know the accuracy. Usually, if you're a bit unsure, you can always look at the measurement that are on the instrument itself and then divide that by 2. Like for example, let's say the measurement is like in 0.5 intervals, then you say divide by 2. Yeah, I'm not sure dividing by 2 is a good idea. You can just use 0.5. So, I mean 0.025. Yeah, 0.025 plus minus. You can use that for your accuracy if you're really unsure of what the accuracy is. But for things like ruler, vernier caliper and all that, you should know it beforehand, so please remember what the accuracy is. And also for your electrical measurements, like your voltage, current, resistance, all those things, you need to know what is the accuracy of the the equipment that you're using. Of course, if you're using a multimeter, you might actually see it written on the screen itself based on the decimal places and stuff like that. But apart from that, yeah, just be careful and aware of all of this. Usually, if your school is good, they will give you a list of all of the accuracies to take note of, so don't worry too much about that. Just remember that, and you have your way of doing it, don't worry. Yeah. So that's for the actual value. For the calculated value, just follow your DP or SF rules. You know what I mean? If you're adding it, you follow the DP rules. If you're multiplying or dividing, you follow SF rules. Okay, great. Yeah, please follow this strictly because this is not theory paper, this is practical paper. So if your measurement may not always be in 3SF, it can be 4SF or it can be 2SF, I don't know, it depends on what you're measuring and how you're measuring it. Of course, you must make sure that all your values have the same, SF or DP based on what you're using as a gauge in the sense, yeah. So that's for measurements. Yeah, then the units, remember what units to write for the table based on what you read in the instructions. And then the next part will be drawing the graph. So drawing the graph will be based on what you're intending to draw, of course. You have the y against the x. So whatever, when they ask you to draw something against something, the something that comes first is the y, and then against, then the second thing is the x. So just remember it that way. Hopefully that works. So the dependent variable will come first, and then the independent variable will come second. Yeah. And based on the equation, or maybe they may ask you to draw a graph based on this equation, and that you can choose to manipulate the equation and then you find a certain value by measuring the gradient or the intercept. So if you have to do that, please do it properly, know what you're supposed to find, use your maths, basically just manipulate it algebraically, and you can figure out what's the dependent, okay, I mean the y variable and the x variable in the scenario. So from maths, you can just make sure the equation is represented as big Y equals to m big X plus C. Yeah, so if you know what I'm talking about, then good for you. And m is the gradient, C is the y-intercept or vertical intercept. And on the graph, please write the correct units because it's not necessarily the thing that the very first data column, but more of like one of the calculated columns usually, especially if you have to manipulate the equation to get it. So yeah, please write the correct thing there, like the correct variable and the correct unit for your y and your x. And when you're drawing your graph, you don't always have to follow the portrait orientation. You can choose to use landscape. Just make sure you are very clear about which one is y and which one is x. Yeah, that's all. You can choose to use landscape. It's perfectly fine. If it helps your proportion of the graph, the scaling of your graph, then you can do that actually. But please make sure the graph takes up a decent amount of space, like your line takes up at least 3/4 of the space there, and your scaling is not too wacky. It should be something like a multiple of 2, multiple of 5, around there. So don't do anything weird. Yeah, just don't do weird numbers. Yeah, so 2, 5 or 10, that kind of multiple will help here. And of course, when you're writing down the points in your graph, like to draw your triangle or something, the gradient triangle, you should write down the points the right SF as well, which will be based on half of the smaller square. So based on what measurement what's your scaling, you have to see what number you would get for half of the smaller square and use that as a basis for your decimal place, like the number of decimal places for you to write. So let's say if for every 10 small squares you say is 2, then you have to divide it by 10 first, 0.2, and then divide it by 1, 0.1, and therefore your all of your measurements will be to the nearest 0.1. Yeah, that's the idea. So please do take note of all of this because they actually are quite important in how many marks you get for your graph, I guess. Like if you do this properly, then you get enough marks. If you don't do it properly, you will lose certain marks, or you may not get all the marks for your graph. Yeah. And the y-intercept part is also important. So if let's say you're not able to get the y-intercept within your graph, it is okay, but you have to then use certain values from your graph to derive the y-intercept. So if let's say you draw, like, yeah, if you're in that situation, you can just pick a random point on your line, and then you use that point and sub it into the equation with the gradient and the y value and x value, and from there you can get your c. Yeah, so I hope that helps. So the next part will usually be calculations based on either the values that you found or any other variables that you have to look at in the whole experiment. And for this part, you will definitely need to know your theory well, like your equations and stuff like that usually, and you need to be good at punching your calculator quickly and efficiently in that period of time. So please try not to make careless mistakes. And if you're very panicky right after finishing the graph, then just take a moment to take some deep breathe, like do some deep breathing, and then continue, or maybe just do it later after you're done with all of the data collection, or if you want to do a different section first, you can do that as well. It's perfectly fine. Just make sure that you finish the data collection for each of the experiments during the time that you're doing the experiment. Yeah. Okay, so for your calculations, yeah, based on the theory, if you know what topic your experiment is in, you can already predict what they'll be asking for. Like for example, if it's electricity related, they'll probably ask you for the resistance, then I don't know, a bunch of other things, depending on which part of the electrics, like what kind of electricity experiment you're doing. Whether it's potentiometer, then you have to see the difference between the the potential difference of the two different wires or whatever that you're trying to measure. You know what I mean? Yeah, that kind of thing. Yeah, but about the electricity related experiments, please be very careful, because I'm not saying careful because you may accidentally shock yourself or something, but more because you're likely to do something which makes the experiment not work. Then you start panicking. Then you'll be like, oh no, what did I do wrong? Then you call the teacher to come over and then help you. So if you're in that kind of situation and your experiment or your setup doesn't work, like the circuit itself doesn't work, or the multimeter keeps saying 0 volts or something, and you're just very confused, do some troubleshooting before you call the invigilator to come over, because yeah, it's usually just some weird careless thing that you did that actually caused it to not work. But of course, sometimes the actual equipment might be faulty, so in case that happens, just tell the invigilator and they will help you get a new meter or a new piece of equipment based on what exactly is faulty, in the sense like voltmeter, ammeter. Maybe the light bulb is faulty, maybe the wire is faulty, I don't know, something might be faulty, and that can happen. But if that happens, just know that that's actually the reason for it to fail, in the sense like the reason why the circuit is not working, and then you can call the invigilator to come and help you. You will not be penalized for that. So yeah, but if it's your own fault, then I don't know what will happen. I mean, you probably won't fail the practical or something, but the invigilator will take note of it. Yeah. So usually if you have if you have some trouble with the circuit, the first thing you should take note of is whether your switch is on or off. I guess that's very important. Or if you're looking at a battery that's attached, like connected to the power supply or something, just make sure, see whether it's on or off as well, like the power supply to the entire circuit. And then make sure that all of the connections are done as per the circuit that you have in your practical exam paper, or based on whether it's the one that you drew yourself or the one that they provide. Make sure that it's followed properly to that diagram and you didn't like mess up the connection somewhere. And also make sure all of the connections are actually properly connected and not like loose connection. If it's loose connection, then obviously it's not going to connect. And then after that, make sure that there is no like oh yeah, if the positive to negative terminal thing, you make sure that you've connected them correctly. Like maybe if you're supposed to connect this positive to positive, then you do that properly. Yeah, so just make sure that you connect everything in the right order as well, the positive and negative terminals. And also there could be a difference between connecting things in parallel and series, so make sure to follow your diagram and do it. So if you've done everything, and I think the last thing you can possibly do is check what exactly is measuring, the like what kind of thing is being measured. So especially if you're using a multimeter, make sure you've actually put it at the right setting, like whether it's current or voltage or resistance, and there's a lot of different things that the multimeter can measure. So make sure it's in the right setting and also the right range of measurement. You should kind of know what range of measurement to expect and then change the knob to the right setting. So don't worry, you will get enough practice on how to use your multimeter, so don't worry too much about that. Yeah, if you need more help on that, maybe I can do another video on it, but I think I might have mentioned this before, I'm not sure. Anyways, yeah, I think you'll be fine, don't worry. Okay, so after all of that is over, and yeah, I think in physics it's a bit hard to really predict what kind of experiments you get, but there's always like this high probability of getting some pendulum related experiment and an electricity related experiment. Then the other two is always other one or other two will always be like some random one which you don't really know. So yeah, anything happens. It's not really like chemistry, which is a bit more structured, the way the kind of experiments that you get. Okay, and the pendulum one always also tends to create a lot of trouble because people sometimes can't really get it to work. But in drastic circumstances, you just gotta do what you can do. Just make the most out of it. As long as you get some reading, it's better than not getting any reading. Yeah. Okay. Anyways, after all of the experiments are done, you can go to the planning section. Yeah. So if you're really finished with all of your experiments really early, and you even finish your calculations and everything, like you're really fast, then go ahead and do the planning, especially if you need extra time for planning. So for planning, you need a good knowledge of your theory for this as well, and for this especially because you need to come up with all of the experimental details on your own. And the main thing to take note of in planning is, of course, draw a good diagram. So make sure that you label your diagram well. Of course, if you really have no hope on your diagram, then at least try to draw it to the best of your ability and like just write all the labels. But at the same time, don't waste too much time on it. Don't try to do some avant-garde art or something. Sorry. Like don't try to do some abstract art or any kind of art in the sense. Just make it look logical, like look like something that people can understand. Yeah, you don't need to focus on the aesthetics but more of whether it makes sense. Like if it's a circular thing, you draw a circle. If it's a rectangular thing, you draw a rectangle. That's about it. Don't need to draw all the individual buttons and all that. Yeah. Yeah, then just draw your, for labeling, you just draw a line straight horizontally and then write the name of what that object is. Yeah, the equipment or the object or something. Yeah, that's for the drawing. And then after that, you move on to the stuff that you're gonna be using, like the materials that you need to use. So in the question, they will give you a list of stuff that you can use, and maybe you might be allowed to use other materials that are commonly found in the lab. So feel free to use whatever number of materials that you really need in that list. You don't need to use everything. They can just be trying to trick you if they want to. So you don't have to use everything. Just use what you think you need to use based on what you're planning to test in the experiment. And please mention what I think it really helps to mention this, even though it's not really required per se. It's good to write down what's the independent variable, the dependent variable, and some control variables in your experiment, because it helps you to understand the flow of your like what you're gonna write later on. So if you know what variables you're measuring, at least you can tell clearly what you're gonna use to measure it, and like what range of measurement to expect and things like that. It's easier for you to write it down later in the actual planning part of it, the procedure. So for the procedure, the main thing to take note of is to write down all of the steps in a clear sequential order. Don't say the measurement before the setup, of course. And of course, if you are talking about the setup, say refer to the diagram above or something like that. And if there's any additional notes on the setup that you need to take note of, you can write it in the notes behind, or if it's something that's really important, you can write it along with the setup of the whole thing. Yeah, and be very clear what are all of the things that you need to measure. It may not be just the independent and dependent variables, but also some other things like the length of a certain thing, or the height from which you're dropping a ball or something like that. So yeah, do take note of those measurements as well, because there may be some constants that you need to keep constant all the time, so they need to be measured for the sake of the experiment. So write everything down. Yeah, and after you're done with the steps for measuring and taking all the data, doing the experiment, everything, then you have to mention what kind of table you need to draw, and you can give an example of the table that you need to draw, as well as the graph itself and what kind of graph you're drawing. You can do your equation manipulation here. Tell them what's the y variable in the, I mean, just write it in the y equals to mx plus c template, and just show the expected graph if you can. If you don't really have an expected graph, then it's okay. Just tell them what to draw against which, like the y against the x, like how you see in your own experiment questions, in a sense. Yeah, so just follow that, and at the end, write down your safety considerations, which I think should be somewhat obvious by the time you're done writing all of the steps. You can think about it. If it's electricity related, you can tell them not to use like wet hands, or not to accidentally shock themselves or something, I don't know. And if it's something where you had to throw a certain object, or you need to worry about certain very heavy objects, then you can write some measures to make sure that they don't accidentally drop anything heavy on their feet or something like that. Yeah, so just take note of those kinds of safety, you know, issues, and suggest ways to avoid that. Yeah. um and then yeah, I think that's pretty much it, right? I don't really have anything else to say. I'm so sorry, I cannot talk properly today. What is wrong with me? Okay. uh yeah, so I think for planning, that's pretty much all we have today. So okay, I think that was a little bit too abrupt. Yeah, so for the actual practical, there is just like all of these things that you need to take note of, like the measurement table, graph, calculations, then yeah, and the whole question of planning. Of course, oh yeah, it's possible that they may ask you certain questions based on what you calculated or what data you've gotten, which is the analysis bit. Yeah, so there's one section on analysis, and it may ask you, okay, maybe is this version of the experiment better, or this second setup better for a certain measurement or something like that. So when it comes to that, you need to know what you're doing. So if you must understand the experiment well, understand the objectives of the experiment, and then suggest which one is better, or whatever they ask you in the question, choose one of the other, in a sense. So yeah, just do that properly. And if you tend to get that wrong or something, it's usually because your data collection was messed up, or you don't really know what the question is asking. So if you have some trouble with understanding the questions in your normal practicals, maybe you can ask your teacher for help, or your classmates to help you figure out how to understand them better, and hopefully you'll be fine during your A-level practical paper. Yeah, so of course, during the actual A levels, time will be tight. Even though it's a lot of time, 2.5 hours, it's still not a lot of time. If you panic a lot, you're gonna be wasting a lot of time. But it is very, very possible to do this with a lot of time to spare as well. So if you're calm and you make sure to follow all of the instructions properly, and if you do face any setbacks, or if you end up realizing that you missed out on doing certain instructions, and you realize that you don't have time to actually redo the entire thing, then just move forward, don't bother with redoing it, because usually even if you mess up, your measurements will be okay. As long as your mess up is not too bad to the extent that it's really skews your data to the end of the world. I think usually your accuracy marks might be not accuracy, precision marks might be affected, but the rest of them will still be in place lah, as long as you do all of your data recording, your graph, your calculations correctly, you should be fine. Yeah, so yeah, I think that's about it. Nothing else to say. Yeah, there isn't much else to say. So if you have any questions about this particular episode, you can ask me below. Or if you want me to do any episodes about literally anything based on H2 physics or relevant to H2 physics, you can ask me in the comments below or in Reddit. And if you have any clarifications or there's something that I said wrongly and you want me to clarify it, then you can also say that in the comments below. But yeah, of course, if you're interested in any particular episode or subject or topic after this, since this is gonna end with this episode, like the new series, or if there's any particular episode like subject or topic that you want me to cover, you can do that. If not, I'll just decide on my own and come up with another video to talk about. Yeah, so yeah, there's nothing else really much to say. So I hope you found this video useful. I'm sorry it was long, but then again, the chemistry practical series had 6 episodes and this is one, so and I was basically stammering some of the time, because not really stammering but more like not knowing what I was, not really being able to talk properly for some reason, so sorry about that. But still, I hope this 40 plus minutes of time was worthwhile, and if it was, then you can definitely press that like button and subscribe. And with that, I would like to say thank you and bye.